Hello guys, welcome back for another video. So today we'll be talking about linear regression gradient descent. So if you haven't watched the previous video, it was also about linear regression but Pearson correlation coefficient, which is a much more simpler function, and you would understand it really good if you're new to ML and algorithms. So today's topic, gradient descent, it's a little bit, I would say, not the whole itself, but the function itself is a little bit complicated because it's more mathematical. And let's dive into it. Let's go. I mentioned in the last video, linear regression last video, here I have made a data file. So you can also make a data file for yourself and have x and y at the top, and then have some random values, decimal or non-decimal. Get to separate them with a comma. So this is very helpful. This is gonna show us well, with the data file we'll be able to see our plots and points, charts really better, much better. So going to the code itself, I have coded it. It's not very complex, but it does have a few mathematical equations that you have to understand. So there are well, some people might have different linear regression gradient descent formulas, because if some people uses different approach to minimize the error, and some people they just use a general approach. So this is the formula that I have used for to find the mean square error, and here we have that formula here, which is finding the total error. And so first of all, let's begin with the beginning of the code. Is this file, and we're gonna initialize a variable to it, and then we're gonna use the pandas read underscore csv for that variable and store it in data variable. And therefore we have our loss function, which we're gonna find out our loss, which we don't actually need it, but it's good to have it, but it doesn't help us with our gradient descent function. So going to the gradient descent function, which is very important. So now we have m now instead of m and b now, because we want how at each point how what's the difference between m and b, so we could calculate that and find the average and basically find the best fit. So L is going to be the learning rate here. It's going to be it's an important variable in this function, because if we have L, big learning rate, then our slope, our step is going to be really big. So we want to have a really good graph, and our points is basically the data file, x and y values from the data file. So going to the m gradient and the b gradient, which is which are the errors basically. So we're gonna loop through the data file, and we're gonna initialize x and y similar to the file that we have, x and y. And so for each x and y values, we want to find the m error and the b error, and the formula for finding the error is right here, is basically also finding the partial derivative. And therefore, as we're finding the partial derivative, basically a sum of the error, or basically a total error, or if you could also say a total the total mean error. And we're going to do that for both m gradient, which is the slope, and b, which is the y-intercept. And here we have our fm, actual m, which we're going to make it equal to m now, and we're going to subtract it with m gradient, which we found, which is the error, and multiply it by learning rate, which it's going to decide how big our steps is. So we're going to do the same thing for b, y-intercept, and we're going to return them. So here we are initializing our learning rate. We're initializing something very small so that we don't get a very unusual graph, and we're assigning 300 epochs. Thing special, scatter is again, it takes some time. We have our values m and b, and this is our linear regression gradient descent. So we can put the data file in the description of the video, but you can also make your own data file. Mine give a weird graph, but it all depends on your values. For example, if you put very small values for x and very big values for y, it's gonna give you a weird graph like mine. So yep, that's it for this video, and I hope that you learned something. Gradient descent is a linear regression. Gradient descent is a important algorithm for the basics of machine learning, and it's better that we grasp grasp and understand how does the mathematical functions work in the background. So that's it for this video. Thanks so much. I'll see you in the next video. Ciao.